reviewing functions. So for our first example, we want to determine if this is a function or not a function. So our first step to doing that is we need to draw a mapping diagram. So we write our input and our output, and now we're going to list our inputs and our outputs. So our inputs are the values listed underneath x, so 1, 2, 3, and 4, so I'm going to list those. And our outputs are the values listed under y, so 5, 9, and 10. Notice 10 is listed twice, but I only need to write it once in my under my outputs. So now we're going to draw an arrow connecting each input to their output. So 1 and 5, 2 and 9, you see, 2 and 9, 3 and 10, 3 and 10, and then 4 and 10. So now thinking about that soda machine example we gave you guys, so every time I press a different button on my soda machine, I get a different drink, right? I'm not pressing 3 and getting out a 10 and then a different value. Each time I'm getting out the same output. So thinking about the soda machine example, we would say this works, yes, so it's a function. Okay? So since every input only has one output, it is a function. So for number 2, again, I'm going to start by making my mapping diagram, writing input and output, and listing my values for my input, 1, 2, and 3. I don't have to write the 2 twice, I can just write it once. And then my values for y, 2, 4, and 6, and 8. Just like we did over here in number 1, I'm going to draw my arrows showing each output of the input. So for 1, my output is 2. For 2, my output is 4. Oops. For 3, my output is 8. And for 2, I also have an output of 4. So since my input gives me 2 different outputs, thinking about a soda machine, this would be pressing a button for water and it giving me 2 different drinks. Okay, it's giving me 2 different outputs each time I press the button. We would say this is a broken soda machine. It's a broken function, so it's not a function, sorry. So when we have an input and it gives us more than one output, it's not a function. Okay, so moving on. So now we're looking to determine if these relationships are linear. So to do that, we need to first think about our change in x and our change in y. Because remember, we have a linear relationship if it's a constant rate of change each time. So my change in x each time, I'm seeing it goes up by 2. 0, 2, 4, 6. It's going up by 2 each time. And my y, let's see, it goes up 5, 9, 13, 17. So I'm seeing each time I'm adding 4 on. 5 plus 4 is 9, 9 plus 4 is 13, 13 plus 4 is 17. So I'm seeing that each time I have a constant rate of change. This is asking me to find my slope. So remember, my slope is just my change in y over my change in x. So my slope is going to be 4 over 2. So we would say that since each time we have this constant rate of change, that this would be linear, okay? A linear relationship. And I could simplify 4 over 2 to be 2. So let's look at our next example. So again, we're going to see how much is x changing and how much is y changing, because that's going to tell us if we have a constant rate of change and if this is linear or not. So I see that my y is changing first by 1, then it goes up by 3, then it goes up by 5, and my x is just changing by 1 each time. So since each time we do not have this constant rate of change, we're going up 1, 3, 5, and only going up by 1 each time on the x values, this is not going to be linear. We do not have this constant rate of change. So we would say that this is not constant and not linear. Okay? So thinking about the differences between these two, again, if we have this constant rate of change, it's telling us this is linear. And if we do not have this constant rate of change, right, 1 over 1 would give me 1, 3 over 1 would give me 3, 5 over 1 would give me 5. So my change in x and my change in y is not constant, so it would not be linear.
So the final thing that we're going to look at today is how to write an equation to represent a pattern. So in our table here, we have a pattern where we have, for each x value, we have a y value. For 2, we have 11, x is 4, we have 17, x is 6, we have 23. We want to be able to represent that as an equation. Now remember what we've learned all year about linear equations. We have y equals mx plus b. We know that m is equal to our slope and b is equal to the y-intercept. So if we can find the slope and the y-intercept from this pattern, we can then find an equation. The first thing we're going to do is find the slope. And remember, our slope is our change in y divided by the change in x. Okay, so what we're going to do is we're going to write here on our diagram, we're going to write our change in x. We see that x is going up by 2 each time because it goes from 2 to 4, 4 to 6. So I'm going to put a plus 2 over the x. And I see my y goes from 11 to 17. I put plus 6. 17 to 23. That's also plus 6. So I have a change in x, that is 2, and a change in y, that's 6. Remember, our slope is the change in y divided by the change in x. So under slope here, I'm going to put 6 divided by 2. 6 divided by 2 gives me my slope. That will simplify into 3. Now, since that's my slope, that's going to go right here in the equation. Okay, so I have y equals 3x plus b. I know part of my equation. The next thing I have to do is find the y-intercept. Now, to do that, since y is equal to 3 times x plus something, what I'm going to do is write up here in the diagram, 3 times x plus blank has to equal 11, right? I have to multiply x times 3, then add something onto it to get 11. Now let's look at this here. 3 times 2 gives me 6. So what's that number we have to add on to get to 11? If you said that number's 5, you're correct. Okay, 5 is that missing number. 3 times 2 plus 5 gives me 11. Again, the 3 is our slope. Okay, multiply by the slope, add on this y-intercept, and we get to the y value. So now I know that my y-intercept is 5. And that's going to go here. Y equals 3x plus 5. We now have our equation. Okay, we're going to put that down here, and we are done with this problem.